Welcome to Arctic Today Research in Focus. Today, we're going to be discussing a groundbreaking new study about how climate change is quietly transforming Arctic waterways, what that means for Arctic ecosystems, communities, and beyond. Joining me today is Bridger Ruyle of the NYU Tandon School of Engineering, who led this study that was published in the Global Biogeochemical Cycle, where it was selected as an editor's choice. We'll be talking about what's behind these shifts and why it matters far beyond the Arctic. Bridger, first of all, congratulations on culmination of years of research as well as the award. Do you want to just begin by giving maybe a quick summary in simpler terms for all of us non-scientific folks out there about what your study found?
Sure, and thanks for having me today, Mary. We were focused on nitrogen loads, the amount of nitrogen that is carried by rivers from the continent and deposited into the ocean. These rivers are very important conduits for a number of different chemicals, such as nitrogen, that are being mobilized in the Arctic due to climate change. And what we were particularly interested in looking at is what is happening to the chemical composition of the nitrogen, because there are a number of different forms of nitrogen that can exist in rivers or in aquatic systems. Some of those forms of nitrogen are what are called inorganic nitrogen species that are very easily uptaken by microbes, by the primary producers in coastal environments that can fuel processing of carbon as well as the negative impacts of nitrogen pollution. Whereas other types of nitrogen, organic nitrogen species, these types of chemicals are much more difficult for ecosystems to process. And so if that ratio or if the relative amount of inorganic to organic nitrogen changes over time, that really could impact the structure and function of ecosystems that are receiving all of this river water in the coastal Arctic.
So you looked at 20 years of data from these six major rivers that flow into the Ocean. What was the biggest challenge in trying to put together all of this different data? Because I imagine various different amounts of data points, many different years that you were looking at. What was that process like of trying to consolidate it to notice these larger changes?
Yeah, actually, there's a really nice data set and a continuous data set using similar methods for the past 20 years that have been measuring um, nitrogen in these rivers, as well as things like carbon, phosphorus, other water quality parameters like temperature and pH. So what's actually nice is that the Arctic Great Rivers Observatory has been running a continuous program monitoring for these rivers and monitoring for these rivers in summertime, where it's very easy to sample, or much easier to sample in the Arctic, and the wintertime, which we know is really difficult to be out in the Arctic during. And so we were actually able to leverage this really nice data set, which is really important for understanding long-term water quality trends. There has been some recent reports from other groups that have shown for the first time that we're starting to observe these recurrent harmful algal blooms in the Arctic. These are one of the things that we're most concerned about for nitrogen pollution, because the algal blooms can cause hypoxia and can poison higher level marine species. But whether or not that is linked to the changing nitrogen composition, or just because we have an overall warmer Arctic Ocean that's also more ice-free, there's a lot of mechanisms that are happening in the ocean that still need to be disentangled.
So the paper obviously talks about the role of permafrost in this changing nitrogen. Can you talk about how you identified that, or what exactly the risks are posed by permafrost, and just sort of break it down again for those who aren't as involved in the scientific research? What's causing permafrost? Why does it matter?
On a basic level, permafrost is soil that has frozen water in it. And the water freezes in this soil because for most of the year, the temperatures are below the freezing point of water. As the Arctic is warming, the air temperature and the ground temperature is increasing. And in a lot of cases, it's increasing past the threshold of water melting from ice into liquid, which is causing permafrost thaw. And so over the past 2 decades, we have seen large declines in the overall area in these watersheds that are underlined by permafrost. And people may be familiar with science that talks about how permafrost loss and permafrost thaw could mobilize a lot of organic carbon that is stored in the soils in the Arctic, and how that could be a really bad negative feedback loop for climate change, because the more carbon that's being released means that more carbon could enter the atmosphere. There's a big concern about how the warming Arctic will release carbon that has been built up and stored into the soils, and how that could further contribute to the levels of CO2 in the atmosphere. But what we don't know as much about is whether or not that permafrost loss will also be a source of other important chemicals like nitrogen that will influence the amount of carbon that can enter the atmosphere. And
Mhm.
so what we found in this study was that permafrost thaw, while it didn't have a net impact on the total amount of nitrogen that was coming out of these watersheds into the ocean, we did find that it affected the relative balance between organic and inorganic nitrogen. And so with additional permafrost thaw, we're seeing a preference for greater amounts of organic nitrogen and less amounts of inorganic nitrogen.
I know you said that you didn't look too much into the ecosystems as a whole, but could you talk maybe about like the bigger picture background about what these changes could mean about the communities who rely on it? I know the study mentioned a lot about the indigenous communities who rely on these marine ecosystems and these food webs, like what the direct impact would be.
The coastal Arctic Ocean is really heavily influenced by river inputs. And the nitrogen that comes from these rivers is the predominant source of nitrogen that is in the oceans. And so we know that the coastal Arctic is already nitrogen limited, which means that the overall size of the ecosystem, the amount of food that's available for things like fish, dolphins, whales, is already limited by the total amount of nitrogen that is coming into the ocean from these rivers. And so if we change either the total amount of nitrogen, or we change the chemistry of that nitrogen so it's less usable by the ecosystem, that would potentially have direct impacts on the overall size and function of the ecosystem. So if, for example, you have less inorganic nitrogen, you can support a, like you can't support as large of a food web. So that means there'd be less fish. That means there would be less higher trophic level species that are often really important, not just for food and for like subsistence, but also for cultural practices. And at the same time, we know that all of the oceans are warming globally, and that's causing a northward migration of fish, of mammals, of entire food webs. So, what we're seeing potentially is an increased demand for food, for the chemicals that supply the food web from this northward migration, but a decrease in the actual amount of chemical coming from these rivers into the ocean.
So that sort of leads me into my next question. Why should people outside of the Arctic care about that? What are the larger impacts of your study?
I think there's a number of reasons to care about the Arctic. As you mentioned in your question, the Earth systems, atmosphere, the land, the oceans, the water is all connected on a global scale. And the Arctic actually makes up a really large portion of the land globally. So even though there's not a lot of people who live there, there's a lot of land, and it's a really important reservoir for chemicals, for species, for ecosystems. And so with climate change, there's a process that's called Arctic amplification, in which the negative impacts of climate change are actually more severe, happening more quickly in the Arctic than they are in lower latitude regions. And so what the Arctic can be used as sort of an early warning sign for the types of changes that we could expect in other areas like the lower latitude regions where more people live, because the processes there are happening faster and more severely. So those will show up eventually also in places where people live. I think the other reason to care about the Arctic is that it is so different from the lower latitude regions like the continental US, and it provides a really good counterbalance in studying the mechanisms of what environmental processes are actually driving and actually responsible for these changes, and how does that compare to what we know about those processes from many more years and much more extensive studies of the places that we typically live. So it can serve as a really good like counterbalance as well.
Mhm. And for decades, we've heard scientists trying to highlight that the Arctic as an early warning system for the rest of the world, that some of these changes are happening quicker. So, on that note, if there was one message that you could send to policymakers based on the data, based on what you found in your study, what do you think is the most important thing that can be done to sort of try and reverse or at least slow down some of these changes that are happening?
I think one note that I would love to communicate to policymakers is we are in a time right now where science funding is really unsure and very unstable. And this study would not be possible without decades of investment from the National Science Foundation, providing consistent funding to develop this continuous water quality record. And that's really special. So things like funding cuts or clawbacks really threaten the continuity and longevity of these important data collection missions that allow us to understand from a scientific perspective what's happening in the Arctic and what's happening with climate change. So that's one side of things that doesn't necessarily affect the sort of impacts and consequences, but I do think it's really important to highlight that these sorts of studies that rely on continuous long-term data collection are really in jeopardy right now in our current political climate. I would say, I think from what to do about it, there's not, the Arctic is so large. You're not going to go out there and do remediation or cleanup in the sense of how you could do that in a contaminated watershed in New York or in California. But what it does highlight is that these changes are happening. They're already happening very rapidly. So anything that we can do now from a policy perspective to mitigate further exacerbation of climate change by stopping greenhouse gas emissions as soon as possible, that is what is going to be the most effective thing at preventing sort of a runaway scenario.
Well, hopefully you all can continue to get funding and continue to look at this research for years to come. Certainly not an issue that is going to be going away. Thank you so much, Bridger, for joining us. We really appreciate it. It's such an important topic. So thank you to you and all of your team. To anybody who wants to read the full study and the Arctic Today article, we'll be linking all of that in the description.